These are going to be the notes for Thursday the 25th. We are going to be talking about 8.2a, which is on our first of two types of what we call special right triangles. And the first one is called the 45-45-90 right triangle. So we've been working with our Pythagorean theorem that says if we know two sides of a right triangle, we can find the third by saying a squared plus b squared equals c squared, and we can find that missing third side. But there's two types of triangles, right triangles, where we only need to know one side, and if we know it, we get the other two. Like over here, if I said, all right guys, guess what? A is 8, what's C? You'd be going, I don't know, you have to tell me B. And that's true for all the triangles, except two very special types. And we're going to talk about this first one, which is actually the easier of the two first. So let's go to our notes, and we are on our 45-45-90 right triangles. So the first thing we have is we know we have a right triangle. We know the side across from it is called the hypotenuse, and the other two are called the legs. But when we have that, this angle is 45, it means that we've really got half of a square. So this triangle made right here on the left is half of a square. Because squares have 4 90-degree angles. And so only if this side is 45 do we know we have half of a square, or sorry, this angle, which means that you always know that these legs are equal because they're actually sides of a square. So when it says when you know a leg, there's two things that you know. The other leg is the same. So if you know a leg, for example, if I tell you this is 5, then you go, oh, this kind's half a square, so this is also 5, which is kind of nice. The other thing we know is that the hypotenuse, I'm just going to write height because that's a long word, but let me write it correctly, right? The hypotenuse is equal to whatever the leg was times the square root of 2. So on this one over here, the hypotenuse is equal to whatever the leg was times the square root of 2. So it's really easy if you know the leg. Now, I don't like to just tell you things without showing you, so I do want to show you why that's the case. So let's go over here and talk about why that's the case. I'm going to make a tiny little 45-45, which means the legs are the same, which means if this one is x and this one is x, and across from the right angle, I don't know. So watch when I go x squared plus x squared equals c squared. Leg squared plus leg squared equals the hypotenuse squared. But for 45-45, because these are the same, I have 1x squared plus another x squared. I have 2x squareds. If I'm trying to figure out what the hypotenuse is, I need to square root both sides. So I go like this. The square root of c squared is itself. And then, if I look at these separately, I don't know the square root of 2. But the square root of x squared is itself. So this becomes, I'm going to put a little c over there, but it's not writing. So c becomes the square root of x squared, which is just x, times the square root of 2. So if I knew this was 7 and this was 7, if I did the Pythagorean theorem, I'd get 7 times the square root of 2 all the time. So easy if you know a leg. Again, don't write this down. This is 11, this is 11, this is 11 root 2. Very easy. But what about if on the 45-45 only, that's all we're working with today, you have to have an angle marked as 45, then you know the other one's 45. And then we know we have half a square, so the legs are the same. Well, the question is, well, what if I know the hypotenuse? So what if instead of there being a 5 on the leg, there was a 5 on the hypotenuse? Well, you just have to go in reverse. So if we multiply by the square root of 2 to get the hypotenuse, we'll be dividing by square root 2 to get back to the leg. So you can see that. Like if I said, oh, psych, I'm not going to tell you what the legs were, guys, but I know the hypotenuse was 5 root 2, then I divide by root 2 to get back to my leg side. Okay, so you're either multiplying by root 2 or you're dividing by root 2. So when you know the hypotenuse, the legs, because they are equal equal to the hypotenuse divided by the square root of 2. All right, so now we need to do some practice manipulating square roots because you are going to be multiplying by square root 2 and you're going to be dividing by square root 2. So on the first side over here, I'm going to tell you to multiply each of these by the square root of 2. Okay, my first one is 6. When I multiply it by the square root of 2, I get 6 root 2. Well, that's not very difficult. That's not. What if I said the first one was 6 square root 2, and I have to multiply by the square root of 2? Then I'd have the first one times another 1. Okay, so if you have to multiply by root 2 and it's just a whole number, 8 becomes 8 root 2. 9 becomes 9 root 2. If there's a root, I still need to multiply the original side by the square root of 2, which would be 6 times root 4, or 6 times 2, or 6 times root 2 squared, and these two undo each other. Either way, you get a 12. What if it was 6 root 3, and I had to multiply by root 2? Then I'd have 6 root 3 times root 2. We can only multiply or divide if the numbers are both under the root or both out of the root. 6 is the only one out of the root, but these two are both under the root. So I can do 3 times 2. So that's how we multiply by root 2. How do we divide by root 2? So my next one is going to have the directive of divide by the square root of 2. Because to find missing parts on these 45s, the hardest math you have to do is either multiply something by root 2 or divide it by root 2. All right, so if my original side was, say, 5 times the square root of 2, when I divide it by root 2, they cancel and I just get a 5. But if my original side was just a 5, and I have to divide it by root 2, I'd have 5 over root 2. And in math, you're not allowed to leave roots in the denominator. There is a historical importance to that, but I'm not teaching math history today. But in order to get it off of the denominator, we'll need to multiply the top and the bottom by the square root of 2. What I wrote there in red is really just the number 1. What is it? It's really just the number 1. And when we multiply by 1, it won't change the value. It'll just do what I call give it a facelift. So now I have the 5 that's out and the root 2 that's in. They cannot be combined. On the bottom, though, I have root 2, which is root 4, or just 2. And that doesn't simplify. But what if I had 6 times the square root of 2? I'm going to go back and use my other marker here. What if and I use 6 root 2 over there, so I'm going to go 8 root 2. What if I had 8 root 2 and I decided, hey, I need to divide that, root 2 off, just plain old 8. What if I had just the plain old number 8 and I said, oh, I need to divide that by the square root of 2? I'll still in red multiply the top and the bottom by the square root of 2. You should have learned this in exponential algebra. The top has the 8 on the outside and the root 2 on the inside. They just have to stay as 8 times the square root of 2. But on the bottom, they're both in. Root 2 times root 2 is root 4. Root 4 is 2. But on this one, these cancel. So I get a 4 times the square root of 2. So that's just a little exponential algebra review. So we are going to have 2 situations. Number 1, where you know the leg. Number 2, when you know the hypotenuse. We'll eventually have to get those on our note card. So you have to go up here and you have to ask yourself, what do I know? And you're going to say, well, that's a leg. And you're going to use what your notes say up here. When you know a leg, the other leg is the same. So the other leg is the same. When you know a leg, the hypotenuse is equal to that leg times the square root of 2. So my hypotenuse is equal to that leg times the square root of 2. It's as easy as that. On this other one, I'm going to say, well, what do I know? I know the one across from the angle. I know the hypotenuse. Well, let's go back here and see what it says. It says when you know the hypotenuse, the legs, they're the same, are equal to that hypotenuse divided by the square root of 2. So my legs, which are x, are going to equal to that hypotenuse divided by the square root of 2. Which is going to equal 44 divided by the square root of 2. But we won't leave that, because we are not going to leave roots in the denominator. We're going to multiply by the square root of 2 over the square root of 2, which is actually 1 disguised as something over itself. On the top, I can't combine them because one's out, one's under. But on the bottom, they're both under. Root 4 would become 2. But these cancel. Lots of 2's in this answer. And I get 22 root 2. So my last one. It says on the softball field, we are trying to figure out the distance from base to base is 60 feet. So in this problem, we've got home plate, we've got first, second, third, and they're telling me all these distances are 60. We know that those are actually right angles in there, or you should, for a baseball or softball diamond. The question says to the nearest foot, how far does the catcher throw the ball from home plate to second base? So again, you're looking for that D. Here's your right angle. Is it the hypotenuse or is it a leg? Well, it's across from the right angle. Here's my leg of 60, my other leg of 60. What do my notes say about when I know a leg? They say when you know a leg, and I proved why, the other leg's the same. Well, we already have that being 60. The hypotenuse is that leg times the square root of 2. So I'm going to do the leg times the square root of 2. But it says to the nearest foot. So you're going to have to multiply that on your calculator and round it to the nearest foot. What that means is if you got 98.3 something, you're going to call it 98 feet. If you got 98.8 something, you're going to call it 99 feet. So the tens place tells you whether to round the whole number up or down to get to the nearest foot. And I'm going to leave that for you because that's the last question on your notes assessment. And then your assignment, by the way, is the delta math.